So, good morning, everybody. Welcome to our next web seminar Wednesday. We are just waiting another 1 or 2 minutes to give people time to join into the meeting and have a look on it. My name is Rolf Heusing. I'm from Composites United. I'd like to lead you to the meeting today, and I'm happy to have you with us. Just a quick technical information for the beginning. As we are recording the meeting to show the meeting afterwards on our YouTube channel, we would like to ask you to keep your cameras and microphones switched off. We will run through the presentation. After the presentation, we will stop the recording, and then we will open the round for the Q&A. So you will have time to speak to our presenters at the end and ask your questions. And, if you have questions in the meanwhile, don't hesitate, just put it in the chat, and we will raise the questions at the end. At this, I will make a short cut. So, good morning, everybody, again, and we will start now with our Web Seminar Wednesday. Let me introduce my two presenters. This is Mr. Joachim Starke from inno-focus and Mr. Amir Ben Assa from Plataine. And I will hand over now the word to you in order to lead us through your presentation.
Thank you very much for the introduction, Rolf. Good morning, ladies and gentlemen, and a warm welcome to our webinar today with the title On the Road to Boosting Throughput, Quality and Efficiency in Composite Manufacturing. It is clear that such a huge title means that we will go into AI and digitalization to give you an answer to that thesis, more or less. First, I want to show you the short agenda, starting with an introduction of inno-focus and Plataine, and of me and my colleague from Plataine, Amir. After that, we will go into a short aspect of the shift in industry, which is necessary, and how this shift can be solved by an holistic approach with digitalization and AI, then some best practice examples for the implementation, and later on to how you can manage this huge area of data sets, how you connect the factory and how this can be achieved. And we will close with a summary before we go into the Q&A. My name is, as mentioned, Joachim Starke. I'm head of product development at inno-focus Digital since 2021. My personal background is mechanical engineering, plastics, processing, project management, and during a long period as well, innovation management. I joined for a while Krauss-Maffei Kunststofftechnik as machinery supplier, but main of my business experience I got at several automotive suppliers. And for the 10 years from 2011 to 2021, I joined BMW Group and were there responsible mainly for the leading edge cluster bicarbon. During all that period, I worked with composite, mainly on the low-cost materials, glass, polypropylene, polyurethane, but especially during this phase with a higher level structural materials, carbon fiber reinforced materials. Since 2018, I worked in the field of digitalization, first for the milling process, that means metal processing, cutting. And since 2021, we started as well to go into the composite and lightweight materials, what we can do with these materials. As mentioned, I joined inno-focus Digital and I worked together since this period, 2011, with the colleagues from inno-focus What is inno-focus? It is a typical SME, a small enterprise with around 25 employees, 25 years of experience, and we are localized in the heart of Berlin, close to the Friedrichstraße. What we are doing, okay, digitalization, but that was not at the beginning. At the beginning, there was consulting with a focus on innovation and nowadays on digitalization. And since around 15 years, we are also working in the subject of software, where we create software architecture, programming, and nowadays as well AI solutions for our customers. And beside of that focused, customized products, we have created our own products, mainly in the application of IIoT technology. Most of you are familiar with inno-focus, but you probably didn't have that realized. The product Carbon Connected was created during the MyCarbon leading edge cluster, together with Composite United with MyCarbon at the beginning, and we are the IT company have created that solution. One aspect that was intercompany exchange of data in that platform at the beginning, where office data were too large, a PowerPoint presentation was too large to handle this via email. And one additional aspect, since a while, we are partnered together with Plataine, and I will use this to pass my word to Amir for the next slides to introduce himself as well as a company. And later on, you will see how we cooperate.
Thank you very much, Joachim, and good morning, everyone. It's a pleasure to be here. I bring over 20 years of experience in the automotive and aerospace and composite industries. I've been with Plataine for the last 9 years, responsible for marketing and product strategy. And I'll be very happy to share my experience with you today. In previous life, I was working for companies such as Siemens and others, introducing innovation and software solutions into the industrial sectors. So my goal today is to share this experience with you guys, and I'll be happy to share our presentation and later on answer any of your questions in the Q&A session. A few words about Plataine. We are a software solution provider, and our software solutions combine AI agents and other high-performance algorithms that solves real-life problems on a few fronts. This could be in planning and scheduling. This could be in the management of material and time-sensitive material, logistics with the supply chain, and also optimizing cutting and kitting processes. This is where we started off. So our solutions complement your ERP systems. This is why we are partners with SAP, and we are tightly integrated to SAP. Also, we are partners with Microsoft. And as Joachim mentioned, we just signed last year an agreement with inno-focus to distribute and resell our solutions and innovation in Germany, Austria, the DACH region, all the Central Europe regions. So very happy to collaborate with a professional company such as inno-focus. So basically, we would like to touch on today with a few topics, starting with the fast-paced world we live in. I mean, the industry around us is evolving and evolving. More products should be produced on the same production lines in many cases. And although the economy in some European countries are flat, we are seeing growth in the aerospace and composites areas. It means that Airbus and Boeing and those companies are dictating more and more ramp up and higher rates and throughputs, and the entire supply chain needs to be prepared for that. On the other hand, after COVID, we still witness supply chain disruptions. And if in the past we would order composite material or any other material, and within a few weeks we would get it, in this period of time, we can wait for a couple of months. So we have to better manage our current inventory, and we also have to make better predictions, not to be short with material, but on the other hand, not to access the cost of keeping our inventory. Sustainability is also a factor that more and more countries, especially in Europe, are looking into. Our factories need to be more green. We cannot just throw away excess composite material. We have to treat it. We have to pay for other companies to make this for us. So basically, we also are more conscious about, energy consumption. We are more cautious about reducing the waste and the 3 R's, reuse, etc. And this is another important factor that we can touch on with our factories' efficiencies. Last but not least, we have very good experienced people that are retiring soon, and we have to bear in mind and to plan how do we get young labor and staff, and how do we replace those great people who contributed for years in the organization, but all the knowledge is in their heads, right? So we have to make sure that the continuity of the knowledge passing and tribal knowledge, and we have also to make our factories and working environment to be more appealing for the young generation, right? Young generations are used to work with tablets, and they are used to work with smart systems, right? Like in real life. So we have to think about this as well. Lucky for us, we have some great technology, and inno-focus and Plataine will present today a lot of advancements that can help manufacturing in the aerospace and composite areas to basically bring more efficiency, improve visibility, use a lot of advanced tools such as AI and IoT and connecting to sensors, but also analyzing and making some prediction and improving our decision-making processes. In the factory, if you think about it, you have many managers, but also hundreds of workers that are making thousands of decisions every day. Some decisions are very simple, but some decisions are based on the rule of thumb and are not optimized. And basically, we can improve that by using some smart software solutions and agents. And if I'm writing today an important email, or I would like to write an article, I'm of course using ChatGPT to help me and reduce the time. So basically, also in the manufacturing area, we have to find ourselves those kind of tools to make us more productive and more efficient. So the inno-focus and Plataine vision is to have an holistic approach. It means that systems should be connected. And basically, data should flow from one system to another, and the processes should be automated, right? So if we're talking about different personas in the factory, everyone should look on connected systems when they're making their decisions. Making the decisions about, planning and scheduling, it should be connected to the ERP and to the demand and to the work orders that are being received in the ERP. Later on, the tooling manager needs to also plan for the different service cycles and the availability of the different tools and molds and jigs. Otherwise, we will have some production disruptions. When we're talking about material, so thawing material, taking from the freezer and putting it for defrost is also important, and make sure you are ready for the production day with your pick list and everything, not to mention the quality manager, and also optimize programs and process engineering that needs those insights and tips, right? So The idea is that, you know, everything is connected now with the cloud, whether these are, you know, the public cloud, or whether this is a more secured government cloud or private cloud, and we support everything. So basically, it's very great enabler to making sure that all those systems and all those people are connected. And whenever you are making a new plan, the tooling manager can be informed, and the material manager, and the quality manager, and so on and so forth.
Yes, I will continue as well with a holistic approach, but my focus is in this slide more how I can do it with that principle. And I will focus at first on the left hand, where you have a sensor or a machine, starting with the computerization of that machine slash sensor, and you need a connectivity to the complex IIoT system where you collect all the data. If you have done it, you can handle this various informations together and bring it to a screen to make it visible. What you have done at that level, you see the information. First time you see the information which often are hidden in the machine, in the sensors, and you are able to detect something. You are able to detect something about the real part which you didn't know before, or which you have stored nowadays. So that means you have created a shadow, a digital shadow of the real part. And what is mandatory for that, you need for each object one ID, which is also very clear and logic if you want to compare the real part with its digital shadow. That in most applications is not there. You have often to create this as a necessary requirement. And that means not only for the workpiece or for the product, as well for the machine, for each supporting material as well, like we have it in the milling situation with the cutting tool. And if you see what happens, you are in the next step much better on the way to understand why does it happen. You start to create theories, explanations. You really understand. And if you have understood why it happens, you are able to be prepared for the future, what will happen next. And you can create for this situation at the beginning some alerts like predictive maintenance, predictive quality is the next step. And it's clear only to prepare by an alert, that is a little bit boring for the the maturation of the complete system. You will create self-optimization, and that is real both be prepared and self-optimization. Here is a part of AI that is then more than the digital shadow. That is now the digital twin with additional information. For that, we are able to support you independent where your company readiness level is in digitalization. And with that, I will pass over again to Amir that he explains some of the examples we have, what is possible with that holistic approach.
Thank you, Joachim. So basically, the first example I would like to share is planning and scheduling. Planning and scheduling is in the heart of every manufacturing factory. And you might think that, you know, there's so much complexity when you're talking about aerostructures and composites and other, you know, high quality parts from lightweight material. But over the years, we managed to handle that complexity. And right now we have many customers that are, on a weekly basis within a push of a button, and in some cases it's more automated than that. We can create very accurate plans that are valid and optimal. Now, when you think about it, you have to think about so many parameters, starting from the process flow and continuing with the number of shifts and available machines and tools and material and the people involved in the production line. And we do all of that, and in very high scales. We're able to schedule automatically tens of thousands of those different tasks, as you can see on the Gantt. And some of our customers are doing it on a weekly basis. Some of our customers are doing it for even 3 months in advance, just to make sure that they have their plan. This plan will be changed, of course, but at least they are prepared for it. Now, what I mentioned AI, right? So this is the beauty of this. It means that whatever takes a very experienced person to do in 3 or 4 days, and of course running and putting off fires, because every time the factory floor is changing, you can have a great plan, but you come Monday morning, Tuesday morning, and 2 people are sick, or one machine needs some maintenance, or a bagging operation is late, right? So those guys are always have to respond to changes, and they're running around their tails, right? With this tool in their hand, they can do their job and stop putting off fires, and they can plan ahead, and they can start to take also midterm and more strategic decisions, and not only to put fires. A factory that is using our AI tool gains 100% visibility over production. Here you can see on the right side, the gray tasks. This is for next week, and they didn't start it. The tasks that are colored in green are already finished, and the tasks that are in blue are the ones that started but in process, right? So we take that information either from our system or from the MES system, that doesn't matter. But the most important thing is that you can gain higher throughputs, more efficiency, and you do it with a click of a button immediately. So this is quite amazing. Another example is to controlling and managing those hundreds and thousands of materials. They could be rolls, they could be spools for our AFP machines, resins, whatever it is. Why to waste time on keeping track with notes or with Excel, or to do manual things, when today there are some automated systems that can do it for you, right? So this is the idea, to handle everything that is out of the freezer into the freezer, the shelf life, the time, all the quality parameters are handled in the cloud, online, digitally, and you don't have to do anything. You can focus on the manufacturing tasks themselves. As the process goes, we are building what we call the digital passport, right? So you start with some material, and then you can cut it, and you have kits, and then you're doing the lab process and autoclave curing, but everything is accumulating to the digital passport for the specific part or project, right? And it could be also spools that are placed in the AFP machines, and this is turned into a product, right? So whatever the manufacturing technology is, for quality reasons and to save a lot of time, we are keeping those digital records, and it's very useful. Another example is around cutting and kitting. Of course, today we have to make use of our short rolls. We have to make use of all of the materials that we have. And whether you are using Lectra or Eastman or Zund, or sometimes factories, they use multiple machines because of their reasons and efficiency, we are agnostic to that, and we can provide automated plans, and to make sure that the entire cutting and kitting process is fully automated and efficient. And in the end of the day, it's important that the projects are cut on time. It's important to reduce the waste, because not only this material is expensive, but now we talked about the aspect of sustainability. So we have to make sure that we cut down dramatically the waste, both from cost perspective, but also from environmental reasons. And that solution gives you very great cut plans that are optimized, dense, and takes over the burden of making sure that you are always making the right plan. The system will take care of this for you, and is the best co-pilot or the best digital assistant for the cutting and kitting stuff.
So I will continue to show what are the critical steps for a fully automatic, intelligent as well as digital factory. So that is more or less a short summary. As mentioned before, you need to collect the data from machines, sensors in real time. Then you have the chance and you will analyze it first by your personal brain, and later on with AI, you are able to optimize and automate things, so that will simplify your personal work, so that you have the chance to focus on other subjects which have a higher priority. And that I will show you in the next steps, in the next slides, for a multi-stage process chain, how we operate there and how we created our tool. First, we start with the elements of the real world. We create the process chain of a typical representative product for that. We implement the data sources along the process chain. And if we have that, we are able to generate data, real data from the machine, and bring them to a platform. With that, as mentioned before, we are able to visualize and to analyze these at that stage, manual evaluation and manual optimize of process or other objects. And then you start to focus what can be optimized, what should be possible by that, what I have seen, what I have identified. But that is a complete new approach in opposite to that manual visualization and manual analysis. So as mentioned before, you collect data for the digital shadow, you bring that to the analyze system, and then you start to use that information for the automatic optimization and bring back the information as well to the platform. And with that, you collect everything and you can create it like Amir mentioned with a digital passport, the digital twin for each part. In the next slide, I show you how we handle this. We have our tool, the Process Data Analyzer, and it represents first in that swim lane all the process chain, beside of that quality and logistic aspects. And with that swim lane, you are able also to get a structure, and you add more information like which machine is it, and as well some aspects from the data from the sources and from the IT structure which is behind that. In this point, we have also what is usable, often used, a switch if you have an alternative process route, or even if you bring that part to another partner, to another company. So that is also possible, and there it means we have also integrated a cross-company process possibility. In the result, you have a document which shows the entire real as well the digital system, And this gives both parties, the OT for the real and the IT persons, a clear overview, good structured horizontal as well along the process chain in a vertical meaning. And by that, it is quite easy to localize the point, what you have to change if you want to integrate further aspects, further sensors, or as well information from the planning area. And what is also possible, you can change your interest from one type of object like a machine or the workpiece itself to another object like the cutting tool. Everything is possible because you have structured the data in the right manner and you are able to switch it. Coming to the visualization, if I would click, and not in this case here, on one of the elements, I see the result, I see the result for a certain object, in this case a workpiece, from the machinery, and all the data from the machinery are visualized in a graph, quite easier than the data collected, which are in a long table of around 1 million rows where all the data are collected. And we prepare that in a standardized graph set for this case. It is an oven from the area of high temperature processing. Everything is prepared, clear view, what is possible, and you can use that as a flexible screen because a zoom in time is possible as well, a zoom for the data itself. So in the same screen, you are able at the same time to go much more in detail. And if there are too many sensor data, it is clear that we add a different and further chart. The second aspect, or with that, you see all kinds of visualization, and beside of that, you have the aspect of traceability of the part, which is shown here in this slide, as similar to that what Amir presented before. For one part, it is shown the process is completed or it is ongoing, or in this case, it has a delay. And here we are able to bring in more information. We are also able to assume or to predict when the process is finished and when the part will be able to receive for the next process step. So that means with that tool, you are able to have a look in detail for a short time of period, what is in real time, what is possible. The second aspect is for an historical investigation, you are able to look which stations, which machines has that part passed, and that is interesting in case of some quality issues. You are able to look on that part to identify a possible mistake, and you are as well able to look on the part before or after that, and you are able to compare what happened there. As well, and clear to understand, with interfaces, you bring also that tools, the planning tools in with a connection from IoT in the direct connection with a real situation in the shop floor itself. And so you are able to react with these programs, with this software modules quite quicker than in the past where it was only a planning tool. So it gets nowadays with a quick information back to a real-time tool. In the next step, or coming to a machining analyzing system. You want to look to several parts, and this we have solved with a machining analyzer, where you can select the part or the parts, the work pieces you want from a table, and you can as well select from the various sensors, the various informations you get from these sensors. In this field, what you will show, what you want to visualize. And in this case, we have a milling process. You see the path of the tool center point of your cutting tool with the additional information of one of the sensor signals with a colored range. Further information is this sensor itself and the power of the spindle as a third graph. And this is quite interesting. That is the programming information which happened at this time in the machine. So you have a direct connection from the program to its answers, to its results. And by the black point, each of the 3/4 diagrams in this case are connected, and it moves if you hover over that diagram and go along this path, and you identify where at what point happened what. So that is one of the USPs, that all data displayed in a linked format. And the benefit is, I think, quite clear. You are able to save a lot of time in the analysis. You don't need a real IT know-how in case of other tools. And it is the base of the AI models when you are able to analyze, to interpret, and create the ideas what you want to see in an automatic way. And after that, I want again to pass to Amir to continue with the presentation.
So we brought a couple of case studies just to provide you with real-life examples of how this is done and what can customers like you can achieve. Basically, our first example is from the US. ST Engineering, Middle River, is a factory producing the nacelles and other parts for the jet engines from carbon fiber. And basically, it was quite an advanced but typical manufacturing site where they were using, on one hand, advanced technologies, on the other hand, a lot of paper in some of their processes and Excel in other cases. And a few years ago, they put a goal to automate the processes, to digitize the processes, and move all the paper, to the cloud and to a digital format, so they can be much more efficient and they could, respond to the increase in demand for those jet engines and aircrafts. Basically, we see here, tremendous results of automation that led to a 10% improvement in material usage and efficiency, 90% first time right, taking down all the rework and quality problems that they used to have because of manual errors and other reasons, end-to-end time-sensitive material management, over 90% utilization of carbon fiber materials, which is amazing, 80% reduction in material waste. We talked about the sustainability, but also think about the cost and the contribution to their efficiency and to their profitability. And of course, all the materials, tools, and resources are digitally optimized, all the cutting and kitting process, and also, the connectivity from their material suppliers is completely digital. So when they receive a shipment, they don't have to use the paperwork and punch in data into system. Everything is done digitally and automatically. The COC files, the quality files, is being received for each and every shipment, and that saves them a lot of time, reduce manual errors, and allow them to be more efficient and to focus on what they're doing the best. This is another company, this is another example from a UK-based company, Multiply, and they are making composite parts for X-ray machines and medical devices. They're not part of the aerospace community, but they are working in very similar processes with the highest quality aspect. And so the processes are very similar. With Multiply, it's all around planning and scheduling that is done today automatically. They have a 3-month schedule in every point in time, and our system automatically schedules in a very detailed and optimized manner their plan. It enabled them to grow and expand their the number of parts they can commit and produce without hiring more people, without buying new machines, and basically make them more agile and quickly respond to changes and rush orders. So if in the past it took them a few days to come up with the plan, today it is done automatically, allowing them to focus on what really matters on their daily production. And basically, in the past, if they were responding to a different change and it took them 4 to 5 hours and caused a few delays, right now they are very agile. They can quickly respond to any change on the production floor and adjust to that, and making sure that their due date compliance is much better. So here we can see a great example of how any manufacturer can use those kind of AI and innovative tools to make the the schedule, and to make sure that you're complying with that schedule. We had a webinar recently with Mr. Lucas Morgan. You have here some links if you get the slides and presentation for the complete webinar, or there's a short video of around 10 minutes that briefly goes over the important aspects. So to summarize our presentation before we move on to the Q&A session, we've touched today a lot of challenges in the industry, but also we showed a lot of tools coming from inno-focus and from Plataine, together with the great services that inno-focus can provide. When you're dealing with those things, we believe that you must take a holistic approach. In the past, we would identify a problem and we say, that's a point solution that could solve this problem. But in today's life, where everything is connected and the information flow is so rapid, you have to think about a holistic approach. How do you connect the different machines and sensors into your decision-making and supporting system? How does the ERP and MES is connected to what the planners and the operators and the managers are doing on a day-to-day basis? How material is influencing the tools, influencing the work orders, and so on and so forth. Another aspect that we've talked about, and it's critical, is moving from being reactive to being predictive. Okay, so it means that basically, that your providers are going to increase rates in the coming months or years. How do you plan for that? How do you plan for a shortage in a certain material and you prioritize other work orders that you can process today? How do you do all those things and still keeping on with production? And the great news is that we have the right tools and some innovation that can help you with that. You're not alone in this challenge. And the same way that we are using it on our personal life, very advanced tools, like our car navigation And you know, we are getting recommendations from all kinds of tools, and we have some personal helpers that help us to write articles and to improve some presentations that we do. Same here in the manufacturing space, we have some great co-pilots and AI agents that can help you in your day-to-day job. They are not replacing you, they are just helping you. IoT, we talked about being connected to all the sensors and whether these are you know, machines and the spindles and the velocity and things that you can control. How you can connect to that, analyze it, and make some optimization based on the data that you collected. And we also touched on sustainability. Basically, more and more throughout the years, we're getting those requirements, and we have to be prepared to zero emissions, to reduce scrap and waste, the 3 R's, you know, and all of that. As we go along and increase our throughput and our efficiency, we also have to keep an eye open on the sustainability goals. So hopefully we covered a lot of the innovation and helping you to be more ready for the coming future and its dynamics. And that is the end of our presentation, Rolf, and we can take it and answer any questions from the audience. So thank you, and thank you, Joachim, for the presentation.
Yes, thank you.
Thank you. Yeah, maybe you finish first, Joachim. Hello.
Yeah. So
thank you very much.
Thank you very much for your attendance. And now I think let's go to the Q&A.
Yes, thank you also from CU side. So it was a very interesting presentation. I think we got a little bit an insight about the new technologies. So I would hope to see you both on JEC as well. So if anybody is visiting JEC next month, you also can meet Amir and Joachim on the fair. So if you're interested in anything, please contact them and schedule your appointment already. Otherwise, I would like to open the Q&A.